So the recording will be posted on YouTube, and then we'll also email that out to anybody who registered through Eventbrite.
Yep, cool. So let's go ahead and get started. So what we're going to cover today is we're going to have a quick section, kind of the goals of obfuscation, then do a AMSI/Defender overview, which will cover also we're going to walk through the SpectreOps funnel of fidelity, just because I think it is a really good method of looking at what Blue's kill chain is and how we can identify the areas where like obfuscation can be effective versus using like a new bypass or unhooking or those kinds of things, which will roll into that methods of detection about like how AV and EDR actually works. Then we'll do some analyzing of scripts and code of like where we can kind of use our intuition and kind of known pieces of information that EDR flag on to start looking at how we'd obfuscate our code. And then once we have a good understanding of how code obfuscation works, we'll look at how we can pair that with some AMSI and ETW bypasses to make that even more effective, because obfuscation has a lot of overhead in terms of the size of our code and the effort that we have to put into getting it passed. So also feel free to post questions throughout the class. I forgot to say that. I will pause every couple of slides to see if there's any questions, and Anthony will kind of queue those up so that we all have them ready. So just a quick overview, if you haven't heard of us before, I'm Hubble, also known as Jake Krasnov. I'm a Red Team operations lead for BC Security. I actually got my start in astronautical engineering, so building satellites and modifying rockets for the Air Force. Then I showed up at a new unit and walked in one day, and they told me I was the new cybersecurity person, and I got started doing testing on aircraft. Now I focus on doing like embedded system security, especially doing some secure design, architecture design stuff, as well as the Red Team operations lead. And then we've got Coin with us as well.
Yeah, so I'm Anthony, go by Coin. Me and Jake met in the military, so lots of fun shenanigans.
Yeah.
That's how we both got our call signs. That's a story for another time. My background is electrical engineering. I'm actually working on my PhD right now in electrical engineering as like my side thing, because that's totally a side thing. And then my background, since a lot of signal stuff, I did a lot of wireless security. So Jake's very embedded focused, and I'm very wireless focused. And then just a little fact, I also enjoy lockpicking. So if you enjoy lockpicking, that's awesome. And then
Yeah, and
Vince is
then
not here today, unfortunately, but he is our actual computer science guy. So if you ever see any of our code, it looks much better than it used to be, all because of him, because he's uber smart.
So I know Anthony shared the slide a couple of times, and we posted a tweet that was pretty popular about the GitHub. But if you haven't seen it yet, all these slides, along with the exercises and tools, have been posted on GitHub and are free to share, and feel free to obviously propagate those wherever you want to send them. And so that's just a quick overview. If you do download it, like I said, it does have the exercises, as long as like the executables for threat check and AMSI trigger. Unfortunately for the threat check exercise, I'll just go ahead and get it out. It appears that threat check has broken in the last couple of months, and I spent like the last day trying to fix it. But I think there's something that changed in the AMSI interface call that's not super well documented, so I haven't been able to fix it yet. I thought it was just the sample trigger he's using, or that's used in AMSI trigger to test if like real-time protection is on or not. That sample trigger doesn't seem to be valid anymore, so I thought it was that, but I went and updated that, and I was still having problems. So unfortunately, the threat check exercise we're probably going to have to skip. But I'm going to spend the next couple of days trying to fix it. If I get it fixed, I'll send an update out to everyone and create a new branch, and then it'll work with the exercise again. So just a quick overview. We're going to be focusing on obfuscation and evasion for .NET code. All the examples and what we're going to talk through are mostly based in PowerShell for a couple of reasons. One, because that's really where the best detections for AMSI and EDR lie right now. Even though we'll talk about it more, even though C# and stuff does have the CLR, which is where C# runs, does have an interface for AMSI, the detections built against those assemblies aren't nearly as robust as the ones in PowerShell. So if you can obfuscate your code past the PowerShell detections, you can probably obfuscate your C# code effectively, or any other .NET language that you want to use. And more importantly, all of the underlying principles are the same. And then third, from an instruction standpoint, compilers add a lot of complexity for teaching. A lot of people spend time, especially people new to this space, spend a lot of time fighting their compiler rather than learning about the concepts. So PowerShell kind of removes that compiler difficulty. So we'll keep doing that. And then also PowerShell is just still used in by every APT and stuff, so it's still relevant. We like to emphasize that at BC Security. So there's actually getting into what we're here for now. There are two primary reasons for obfuscating code. There's to prevent reverse engineering, which is where most of the research and stuff comes from. There's actually kind of this irony that a lot of the obfuscation techniques that we'll teach actually come from people trying to protect intellectual property that were adopted by malware developers or red teamers to also obfuscate their code. But the original intent of it was to do IP protection. So if you really want to nerd out on obfuscation stuff, the best way to go find up-to-date papers is go look for reverse engineering protections or intellectual property protections in the academic space. And there's tons of papers being published there on how to prevent reverse engineering. They're all from the protecting codes standpoint. The other reason that we do obfuscating of code is to evade detection by antivirus and hunters. There's hunters we'll talk about a little more because there's actually kind of a bit of a paradox when we're trying to prevent detection by active hunters. But antivirus, we're just trying to break up the way they detect our signatures and those kinds of things. Because antivirus, we'll talk about antivirus is kind of just like your static code analysis type of thing. And then EDR is where you get into your behavioral analysis. But most antivirus is just doing your static code analysis. They may do a little bit of sandboxing dynamic code. So Anthony, are there any questions so far?
Someone just said, cool tip. How do you like to search for those papers, and do you have any recommended sites for them?
I mostly just use Google Scholar a lot of times, because unless you have an organization that has access to the research papers, it's a little hard to find them. But yeah, mostly Google Scholars, and I just look for code protection papers is usually what I Google, along with reverse engineering, obfuscation kind of stuff. So as I already talked about a little bit, preventing reverse engineering is something that both the commercial sector is interested in protecting their IP, as well as threat actors. So this is less relevant for red teams a lot of times. We're not really that concerned about whether or not someone's able to pull our malware sample into a lab and spend 2 weeks analyzing it and finally figure out how to decode it and all that kind of stuff, because usually the timeframes we're operating on aren't that long. So the reverse engineering piece after the fact isn't that much of a concern for us, although some people still like to put it in there. More importantly, from the preventing reverse engineering standpoint, from a just basic side, is we want to hide our infrastructure, things like that. You don't necessarily want to give away your C2 address, what communication channels you're using, or at least make them easy to see, or where your other internal pivot points are. So when you do, if you've ever, Cobber, I believe it was, posted a really interesting paper when he designed his SMB infrastructure for Covenant, about all the different ways to manage multi-channel peer-to-peer comms in a C2. Like one of the downfalls that you have to be careful of if you just kind of give everyone everything is that as soon as one implant is found, it exposes all of your implants if they have the entire list. So you can do things like just having the edge nodes talk to each other, but that's less code obfuscation, more C2 mechanic stuff. But those are the kinds of things that we want to protect so that we don't like burn all our domains. Like, so if you have an agent that has all the domains, you want to try and protect those names and those kinds of things. So evasion's the other piece that we're trying to do. It's kind of like what, like we've named this class after, because it's what we're focusing on. We are not focusing on the anti-reverse engineering piece, although there's some really interesting things we can do. That's not the focus for today. We're going to be looking at the evasion part. So evasion isn't just obfuscation. Evasion can be disabling security software. So that's where you like unhooking DLLs, patching AMSI, which we'll talk about, patching ETW providers, those kinds of things are disabling security software that aren't really code obfuscation. Then there's obfuscation, which is obfuscating the code from being read in like static signatures and even sometimes dynamic signatures, depending on how we manipulate our code. Then we can also do things like trying to blend into network traffic or into the normal operations of the network. Actually, our first exercise is going to be looking at some of that stuff to just kind of show some of the pluses and minuses of obfuscation and things that we want to look at from a attacker's perspective when we're looking at some of the information that's presented to Blue. Then we can also look at third-party communications. That's where things like DNS over HTTPS come into play. If you get into some of the more weird stuff where you're using like OMG cables to have like a wireless access point so that you're not actually going out over the target's network. Those third-party communications are also evasion because you are using your command and control over a way that can't be collected, or at least is more difficult to collect. So evasion allows us to change our indicators of compromise and extend the response time of defenders, but it doesn't allow us to erase all our indicators. So like, I'm sure a lot of people know, but if you ever see like some of the gray market stuff or even black market stuff you've seen where they start talking about like the fully undetectable payloads and that kind of stuff. There's no such thing as a fully undetectable payload. It's just they've changed their indicators to not be what people are traditionally looking for. There's always indicators. There's something you're doing on the box that can be fingerprinted. Now, sometimes those indicators are so common as to not be all that useful, but there are always indicators. It's not possible to do something that provides no forensics indicators. So when I say indicators of compromise, like I said, that those are forensic evidence of a potential attack on a network. Those include things like writing a new file to disk that wasn't necessarily there that the user didn't know about, network requests to a unknown endpoint, a thread trying to access another process that it shouldn't be. Like a really common thing nowadays is like if PowerShell.exe tries to touch LSAS, regardless of whether or not any code did anything was identified as nefarious, a lot of EDR just go, there's no reason for legitimate reason for PowerShell to be touching LSAS, so we're just going to kill PowerShell. So those are a couple of different examples for indicators of malicious activity. Anthony, do you have anything else, any other indicators that you kind of keep track of?
No, not at the moment. Sorry, I was
Okay.
trying to help somebody get into Discord. I apologize.
Yeah, no worries. Do we have any questions right now?
None at the moment.
Okay, cool. So as I mentioned, we're going to talk about Blue's kill chain, which is the funnel of fidelity, which means the funnel of fidelity is a way that Spectre Ops, or a method of analyzing like the SOX operations that Spectre Ops published, saying that these are all the steps you have to complete in order to an effective remediation process. That a failure at any point in the funnel, as they refer to it, a clog at any point in the funnel, results in a failure of Blue being able to do their job properly. They originally designed it as a way to help Blue analyze where their process was failing, but it is also a very useful way for us to think about how Blue is doing their collections and what pieces we can attack. But it starts off by starting with weak indicators to create your initial detections, and then you step through it going a little bit at a time as you shrink down, getting to less and less pieces of information to deal with and less events to look at. So you'd start off with like kind of detection, which is hundreds of thousands of events. Then you'd go to triage. So triage is where like the SOC starts getting involved, and they have like hundreds of alerts. And then you go to your investigation, where someone at the SOC has said, yes, this is probably someone has said it. And then remediation, which is hopefully only singular events going on over certain pieces at a time. So parsing logs with Event Viewer is really interesting because it gives us a way to kind of do like a quick and dirty analysis of like how Blue operates. So Event Viewer is an application, if you've never used it, is an application for interacting with the majority of system event logs that Microsoft produces, or sorry, Windows produces. It's often accessible as a general user, but you can't modify the logs. Just a little tidbit in here from operations. PowerShell logs are a good place to check for admin credentials. Sometimes people hard code credentials into their scripts, and while the general user may never go look at that, if you're an attacker and can dump the PowerShell logs, you may be able to find some interesting information there. You can also use other command line tools though to parse logs, like PowerShell has get event log. Log parser is another tool. Python etvx is a Python-based log parser. So we'll go through this in a second on how you open Event Viewer. Once we get to the exercise, I'll walk through this. So some of these are just these slides are just for reference so that you have them. So if you ever want to go back and look at it and say like, how do I go look at these PowerShell logs? You have some slides that'll walk you through that process. Yep, so this is the location of the PowerShell logs. Like I said, we'll walk through this in a second. So we're just going to go ahead and look. I'm going to pull this up, and since we do have the chat working, we can kind of get some input from people. So I'm going to open my, where is, I'll just escape from this. Oh, why did that stop sharing? So let me turn my virtual machine on. So do we have any questions or anything right now?
Nope. I think they're trying to help. Oh, someone said there's a typo on one of the slides. Probably. I think it was the Python EVTX thing. Somebody on the Discord asked, is there a VM we're supposed to download? You actually don't need a VM. I mean, you're welcome to use a VM if you don't want to run things on your bare metal, because you will be running sort of pseudo malware-ish type things. So that's up to you if you want to run it in a virtual machine or run it on your desktop.
Yeah, so we did get asked if there is an Empire payload in the event logs. There is an Empire payload in the event logs. Event logs sometimes is really slow to open.
Corp laptop for the win.
Okay, there we go. So we'll go start at the bottom of the logs. I mean, loading it up on your government laptop, it'll probably be fine. They don't actually tend to care that much. Okay, so unfortunately, I don't think there's a way for me to zoom in on this. We've tried before when we're using Zoom. So I apologize for the event logs being smaller, but I will zoom in anytime we're using like PowerShell or anything else for the rest of the class. So you see we've got, like, this is just a random, someone was running like a write host test and to make sure the logs were working. By someone, I mean me. So the first one that will, oh yeah, I can definitely do that. 1 second. Go away, Zoom.
You saw the full screen message? Okay.
Yeah. My full screen button is not full screening though. There we go. Okay, Anthony, can you guys still see it?
Yeah.
Okay, cool. So in the first log, the first kind of interesting event that'll come up when you're looking at the logs is at like 6:58:57. I can't see the chat when I'm in full screen like this. So does anyone know what this is? And Anthony, you can tell me.
I'll read it off.
Yeah.
If anybody answers it.
Or does anyone think this is suspicious? Did we get any guesses, Anthony?
Someone said system, it's using VSS, shadow copies, copying the payload.
No, so this is actually the Hive Nightmare vulnerability that was published. Time runs together. I can't remember if Hive Nightmare was the beginning of this year, if it was last year.
Rick said system Hive. So
yeah, so you're dumping the system Hive. It allowed an unprivileged user to dump the system Hive and basically get credentials to anything. But as you can see, like if you're not a not necessarily like a well-versed defender, this doesn't immediately set off like a bunch of flags because it's just like we'll look at some other scripts as we go through this. That like system IO file and like copying files is not nearly as suspicious as you would hope it would be, because sysadmins like to do sketchy things.
Jake, if you do the next one, I'll put up a poll and we can have people guess if it's an Empire payload or not.
Yeah, so this is also showing a bunch of, I actually made a typo when I was running this the first time producing these logs. I was trying to dump it to a non-existent file system. So it's actually in there twice. This is the proper call to it.
That happens though.
Yeah, that happens in real life operations. So that's the basic system call.
Here,
okay,
this one.
So this one, let's see. What do people think this is?
Well, let me create a poll. Oh, it's gonna make me do weird login stuff. I'm creating a poll right now. I want to see what people say.
Just I want to vote on malicious or not.
See if it lets me do it. Launch it. There we go. Cool.
Oh, it gave me, it's asked me to vote, and then it tells me that I'm not allowed to vote.
Oh. We played with Empire a bunch. This should look familiar. Someone said 100% malicious. It's a base 64 encrypted PowerShell. Yup. Okay. So
are we gonna move on?
You're going to talk through it. We have about 85% of them think that it is malicious Empire stuff.
So this is actually not malicious. This is a code snippet that I took from a system running from a company that was running AirWatch, which helps with like automation and that kind of stuff. AirWatch runs everything as base64 encoded PowerShell. This piece of code's actually broken. It doesn't even run anything, but it's also trying to like pull an H key local machine system key, and like their PowerShell logs were just with this kind of stuff. So base64 encoded PowerShell was super, super common to see on their network. And this is where we're getting into kind of that, like when I showed that funnel of fidelity earlier, this is where we're getting into if you can hide in that normal traffic, or they're unable to differentiate your code from common code that is occurring on their network, then it doesn't really necessarily matter if it like is the coolest tool or not, because like this, a lot of networks have lots of base64 encoded PowerShell. Actually, if you go to talk to sysadmins on like some of the PowerShell discords and stuff, it's actually a big frustration from them that a lot of the SOCs only base their detections on whether or not the PowerShell is base64 encoded or not, because sysadmins need if they want to do any kind of automation with PowerShell, most of the remote tools expect the PowerShell code to be provided in base64. So it causes a lot of conflicts with sysadmins on live networks.
You tell the story about one of the ones you found.
Oh no, it's in here. It's in here.
Oh, it is. Oh, even better.
Yeah. Okay, so here's another base64 encoded PowerShell. I don't want to spend too long going over logs, but this one is a Empire payload. You can tell like it's a little longer, so that's kind of a bigger giveaway. But again, a sysadmin might be running a log. Also, if you've done this enough, like because Empire payloads, and you can go change this if you want. Always start with like the if PowerShell version. The base64 is always the same on the front. So if you ever see like SQBM, like 90% chance is probably a PowerShell or PowerShell Empire payload if it starts off with that. But as you see, like in our logs, PowerShell, like with this is one of the reasons that people have moved away from PowerShell is the way AMSI and script block logging works. Is that this you actually end up seeing the obfuscated code as it goes to get ran. We'll actually talk about how you can still obfuscate this in a second. But it gets undone as it keeps following it down. So you can see like more and more pieces of the code as it goes through its execution. So here's another one. Let's see what everyone thinks on this. This is someone dumped in a code of using a whole bunch of system stuff and doing some pinvoke. So we can scroll through this. This one's, if you have the logs open, this one's at 6:59:55. Let's see what people think this is. Oh, we're even using some unmanaged pointers and stuff in here.
Someone said that the logs don't match up for them.
I'm not sure about that because this I pulled this straight out of the.
You should have put out of the
folder.
Out of the folder. Off the GitHub?
Mm-hmm.
Okay. Oh, it might be time zones.
Oh yeah, it might be time zones. That might be what it is. Because I did make it on this laptop. So
yes.
Yeah, it might be time zones.
Someone said possibly sharp RDP. Seatbelt. MS build for C#. Got a couple good answers.
Yeah. Let's see. Let me scroll to the bottom. I'm like 90% certain this is the correct one. Yeah, no, this is the correct one. Okay, so I would agree with everyone that this is a super suspicious script. This is actually a script that I found on on a Fortune 100 company's network. I thought they had been compromised, and it was actually their sysadmins were running this every 45 minutes on their network. They were using it to get where users were logged in to track like user information for like updates and that kind of stuff. And basically, I think I took it out of here, but there was like a comment at the very bottom that basically said I found this on GitHub and I can't write it better. And so they were using it for that.
I mean, it looks really suspicious with all the
it
stuff.
looks super suspicious. Running PowerShell with basically like using add type to compile C code with a bunch of, or C# code with a bunch of pinvoke stuff. It looks super suspicious, but that's what they were doing. Oh, here's another Empire payload being ran unobfuscated. So let's see. I think those are the major highlights. So just more Empire stuff. Oh yeah, so this is where an actual Empire payload that connected. So the first time it ran, it didn't connect back. So this is the next stage being shown in the code. Let's see. So just another note for some people that is good to know. Anything that's at this warning level, so where you see that it says warning and it has that triangle, will actually be populated in a script block log, whether or not the target has script block logging turned on. There are some keywords that trigger it, and there's ways to get rid of that, but it is a word to note that there are certain things will automatically get logged even if script block logging is not actually turned on the computer. Oh, so this was I put this in here because this was this is a malicious PowerShell script on how to retrieve logon information about various users from Climber. And I put it in here to show that basically that other script that was being ran with the C# stuff was doing the same thing, but was being done by a sysadmin. And it like basically lined up with what was being done by this malicious PowerShell script that's out there. So those are all the highlights for this exercise. I will see if it lets me get out of that. So let's see, are there any questions before we start moving on to, we're gonna just talk a little more about like deep down into that. I am in Central Time. This is what those logs should have been created in.
Besides that, I don't see any other questions, Jake. So
okay,
I think you're good.
Yeah. So now that we kind of looked at that and like how
Can you
like
go full screen, by the way?
Yeah, yeah. I was about to get there. Cool. Now that we've looked at that and we've kind of had like an example of the type of information that Blue is looking at, we're going to step through just a little more in depth on what this funnel actually looks like from a step-by-step perspective for Blue. So the first step of the funnel is collection. It's made up, if we look at the funnel, it's this actual arrow that's going in. It's basically impossible to avoid collection in some form because it's data just going across the network. And like if they have a firewall tap that they're doing packet inspection, if they're correcting net flow data, if we're executing PowerShell, all that stuff is collected. That doesn't necessarily mean that they're doing anything with it. They may collect it and file it away for later use. They may only use that data to do certain types of detections, but they are collecting the data. It's the most difficult to avoid, but we can avoid it. Like, you know, script block logging and how that's collected and shifting over to C# is like a perfect example of doing collection evasion. Of we just move our TTPs as a whole, like wholesale, into another format. Then that is a way to avoid it, but it's pretty hard to do that. It involves a lot of overhead. It's and like I said, we're still going to be collected in some way, even if we're avoiding the PowerShell collection logs. We're still producing ETW events that are being collected, all those things. So collection is good to be aware of and avoid where we can, but we usually can't avoid all of it. So detection, this is where like kind of where detection and triage are kind of where our obfuscation lives to be effective. Defenders start determining what is malicious and what is not. For the most part, detection is done via automation. This is where we can be really effective with, probably our most effective with our obfuscation, because we'll talk about least obfuscation in a second. But this is kind of where we live and breathe with like the really hardcore obfuscation if we want to prevent the automated stuff from even flagging us in the first place. Another thing that we do have to worry about sometimes is like network indicators. Those are, we can't do as much about those with obfuscation, but it is something to keep in mind. So things like known user agent strings, like most C2s have a default user agent string that's already fingerprinted by most IDSs and IPSs, high entropy byte strings in an HTTP post message. So like basically it indicates the data is encrypted when you're not using an encrypted protocol. So that's suspicious. Unusual communications with internet or other machines, and then external attempts to log into infrastructure, just some like really high profile network indicators that you may want to, I threw in here as a, hey, you may want to avoid these kinds of things. So once we get into triage, we're starting to get a little more scrutiny from defenders. This is where manual review is being implemented. So all those fancy EDRs, IDSs, and AVs have flown all the data to the SOC. They said, hey, I think this is malicious. Go look at it. So that's why one of the reasons I was saying, like I threw in the network indicators as well, is when they're doing triage, and especially when we go into investigation, we may be able to do something like where our code wasn't initially suspicious, but a network indicator gave us a way. So they go look at our code and they go, wait a second, that code doesn't look right. And they go investigate it further. So just being aware of it's really good, because even if your code is kind of obfuscated in a way that you get past the automated stuff, other things might cause like a defender to go look into it further. Defenders are trying to sort like the false positives from the real alerts. That was one of the points of those logs that we looked at. Like if you're a defender searching through those PowerShell logs, it's not quite as clear cut as a lot of people like to portray it from a red team perspective. When you talk to a lot of red teamers and they're like, oh, PowerShell's dead or C# no longer relevant, you got to go write your stuff in C because they can collect it. Those statements are true, but the SIEM is getting the SOC is getting so much information that a lot of times it's really not that clear cut. So like, what if they did collect it, but PowerShell, base64 PowerShell is so common on their network that they just automatically mark it as a false positive because they see it 90 times a day and they're just like, oh, it's just another false indicator. So like playing against how the SOC is actually operating rather than what did the automated tool collect, I think is a much more effective way of building our TTPs. Rather than trying to necessarily focus entirely on evading technical controls. Attacking the process is also very effective. And so, like I said, alert fatigue is a major struggle for many organizations. There's just so much data coming in that they can only do so much with it.
Do we have a lot of blue people on? Just wondering, see what our mix is. No, we do get a couple.
Yeah.
Smurfs.
Oh yeah, you should put up a poll, Anthony.
I'll do another poll. That's fair. While you're talking.
Yeah. So step 4 of the funnel is hands-on, is investigations, hands-on analysis is beginning to happen. This is where, so a SOC may not even be getting all of the information. Local machines may be storing additional logs in case an investigation happens. They're only sending like pieces of the information back to the SOC based on the alerts and configurations. But when they go do their investigation, they're starting to actually go look for specific activity artifacts like binaries being dropped on the system, additional files being added, those kinds of things running in memory that aren't normal, those kinds of things. And at this point, an activity has been confirmed to be of concern. When you go into investigation, it doesn't necessarily mean that it's been identified as malicious. It's been identified as concern. A SOC analyst has looked at it and said, this is concerning enough that it warrants someone else going to look at it. So, because a lot of times a alert may be suspicious or activity may be suspicious or, but not actually malicious. So, you know, some guy on the web, on the network read about some weird exploit and that just got published, and he decided to go see if it works on his computer, and all he did was run it and put a file on his desktop through Word or something like that, and that's the extent of it, and there's nothing else to go look at.
We actually have a straight split, like 52%, 51% red. So interesting.
Interesting. So the so kind of the final step in remediation, or in the funnel, is remediation. At this point, we've lost the battle, not necessarily the war, but they've identified that there's something wrong on that box. In a well put together organization, they're basically going to go golden image that, and it's kind of game over. Less well put together organizations, they may try to just remove the malware and then put the machine back out. In that case, you can try hiding, but most organizations don't do that anymore. It's easy enough to just kind of golden image a box when you've identified that something's wrong with it. So more importantly, we want to try and not give away other infection point or other where the other infrastructure lies. So things like having your agent kill itself after not being able to communicate with the C2 server for so long are useful here, because it means that it'll kill itself off, even if like blue doesn't turn the box off or that kind of thing. And helps prevent, like, if they have a few hours before they can go investigate the box, hopefully the beacon has been disconnected long enough, because they disconnected the box, that they that the memory forensics can be dumped before anything gets discovered. But that's kind of, like I said, at that point, if they're remediating the box, we've kind of lost that battle, and we're going to move on to other points. So as we mentioned, the funnel is effectively the blue team's kill chain. If we can break or exit the process at any step, we have effectively not been detected. So like if we can make remediation not occur, then we still have our implant, and we can keep operating. If we avoid collection, the data never gets collected, that step stopped, so on. So how do we go about breaking the funnel is kind of where we get to, and where our obfuscation is going to come in. So we get, as I mentioned, we can try to beat collection traffic, but traffic has to go through certain pieces of infrastructure where data is being collected. If we can identify a collector, we can potentially disable it. Like we disable script block logging, that's pretty easy. We can turn off net flow collection on a router if they're doing that. If you get into more of the infrastructure, attacking the infrastructure rather than just attacking like the Windows boxes and those kinds of things. So detection is where, avoiding detection is where we spend most of our time as a red team through our obfuscation. We want to either blend into standard traffic, obfuscate to avoid our signatures, and then follow, like, so this probably should have been tabbed over, but follow normal traffic flows is like really important. I think there's been a lot more awareness about this in the red team community now, and others, but a random machine logging into a router, probably not like normal behavior. A SMB connection from a workstation to a workstation, probably not normal behavior that'll get collected. Those kinds of things we want to avoid. So triage is starting to get a little more scrutiny from our defenders. Like we said, we can blend into the alerts and use the AV logs, see if anything causes a lot of alerts, and abuse that alert fatigue, and abuse assumptions about like, is this normal for it to be on the network? Investigation is kind of where we're getting into things that are going to be difficult. Investigation, we can extend out their response time by stomping on logs or obfuscating our payloads, or hide. Like if we see a technique that I've seen employed by some threats or APTs is they will have like a list of like hunting tools that they periodically have the implant check for in the process list, and they see that, then the agent shuts itself down because they know that like there's something that's going to catch them there, so they just shut it down and they hide and wait for like that stuff to go away. So that's kind of the overview of the Blue's process. Do we have any questions? I know this is a little theory heavy on the front end, but I like to teach the theory stuff and then we get into the hands-on stuff. So we're getting closer to the hands-on stuff.
We had to build a whole course on evasion just for Jake because he loves this stuff so much. I don't see any questions at the moment. So.
Okay, cool. So now we're going to go over like how AV and EDR do their detection when they're actually trying to find like in-memory implants or even just scanning files on disk. So AV we're going to start with like the simple and get up to the more difficult. The static detection methods that AV use, the best known are hashes. You hash a file, compare it to a database of known signatures, and then see if it matches. Hashes at their most basic when AV first started was they would literally take the whole file, hash it, and then compare it. Any changes to the file would break that hash, and so it didn't work. Byte matching is another interesting one. That's where they're saying like they're taking it and saying, okay, we know these sequence of bytes is a malicious. It's someone trying to patch AMSI, and they look through the whole file to determine if those bytes that series of bytes are contained anywhere in the file. So they can look for, this is where you kind of get like some of your keyword detections, like Mimikatz or potentially known like object structure that they can look for, those kinds of things. But the problem with byte scanning is it's slow. You have to look through, like you're trying to find like an exact match. So instead you can do what's called hash scanning, which is a hybrid of the above two methods. So instead of hashing the entire file, they hash files in chunks and then compare the hashes to look for anything that could be malicious. This is one of those things, this is one of the reasons that like some of the methods that we'll talk about in a little bit work is because hash scanning is still saying like we're going to chunk every 100 bytes and then compare those hashes. Well, if we could shift the code structure around so that our signature no longer falls in those hashes, then by shifting it, say we pad it 50 bytes, then they may not be able to find that hash anymore. They have some more like AVs absolutely have more complicated algorithms for detection to try and combat that kind of simple, like we just padded it 50 bytes so your hash doesn't work anymore. But fundamentally, we can still try and fall on like where, like break up our code because we know that like these three words together are malicious, but they don't actually have to be together. So we can put one at the beginning of the file, one in the middle, one at the end, and now the hash scanning won't find it anymore. So heuristics are another static method that we can use. Those are things like file structure, like detecting if an exe has been packed in the header, like you can look for entropy, things like that. You can look at logic flows, which are like looking at how an abstract syntax tree is laid out, or the control flows, which starts getting into some of the, like I mentioned, there's a whole reverse engineering, like IP protection stuff, and they get into some of that like really complicated like control flow analysis and stuff like that. I haven't seen any AVs actually implement it. There's a few papers out there on how you would use it for AVs, but I'm not aware of any EDRs that are actually using it internally yet, because it's pretty complicated analysis. Then we can also do rule-based detections, which are kind of typically using like a combination of hash scanning and some of these other things. But you can think of them as context-based detections. It's if X and Y, then malicious. So like if you see like download data and RC4 encoding, then it's malicious, but RC4 encoding by itself or download data by itself is not malicious. So they'll do, and that's kind of where, or that's how a lot of modern AVs and EDRs are working together. But
Jake,
most of them use some kind of aggregate of all of these. Yeah, I saw the question, Anthony.
you did? Okay.
Yeah, finish my thought. But so a lot of them will use an aggregate of risk for the probability of a malicious file. And then we got a question asking, when you refer to AV, is it the same as EDR? No, it's not. So AV can be kind of thought of in like two ways. It's almost always primarily an antivirus, antivirus, always a static analysis engine. They're not doing what we're going to talk about on the next slide with dynamic detection methods. Like an AV is not putting it into like a sandbox typically to detect things. And then the other thing that I have noticed from that I like to use as a differentiator between AV and EDR is that AV is typically only aggregating detections from a single detection source, whereas EDR is using an aggregate of multiple detections. So like ETW plus the static code analysis plus maybe something else. They're using multiple sources of data to build their detections rather than like a single source, like a static string analysis or like just PowerShell logs or that kind of thing. So the dynamic detection is like our behavioral analysis. This is where we're really getting into EDR. So it's classification detection, it's sandboxing, it's the system logs and events, it's API hooking. So looking at the API, like hooking APIs, like when you call like an ETW event or you call looking for like write protect, they'll sometimes hook the write protect call and those kinds of things. 1 second, I apologize, guys. My parents' dog is going crazy. I don't know if can you hear that, Anthony?
Yeah.
Yeah. Okay.
I was trying not to bring attention to it.
Yeah, I apologize. I think she's calmed down. Apologize for that, or not.
Someone said just tell them they're a good girl or boy.
I apologize, guys. So, well, does anyone have any other questions about that? I kind of lost my train of thought there a little bit. Okay. Nope, no other questions. So now we're going to specifically talk about AMSI and how fileless malware works, because it's probably the most important, it was probably the biggest like watershed moment for AV introduction. About how to detect like in-memory payloads. So like, or when we talk about like our PowerShell payloads and those kinds of things. So this is the like very wordy Microsoft definition of what AMSI is. If I'll give you guys a second to read it. So it's on there. You guys can read it, but it's very wordy. You know, it's great, but what does that mean? The big takeaways from it is that it was introduced to identify fileless threats and it evaluates commands at runtime, which means that prior to AMSI being integrated, a lot of malware was using things like RC4 encoding or encryption and other XOR encoding, those kinds of things to thwart AVs, because those encryptions were really easy to make it so that the signatures and static-based methods they were using changed constantly. But because of the introduction of AMSI, which is integrated in a whole bunch of the scripting languages like PowerShell, JavaScript, VBA, along with the COR now as a .NET 4.8, those interfaces are implemented in a way that the code has to be compiler readable, which means that those XOR encodings and RC4 encryption and stuff like that have to be undone prior to it reaching AMSI. Otherwise, the compiler wouldn't be able to turn it into executable code. And so that made a lot of the TTPs at the time much, much harder to execute. It also removes some of our options for obfuscation. So that looks like this is what it looks like in memory. You have all of your PowerShell, your VB script, and your other applications that interface with the Win32 API layer. It goes down through there. The other big piece about what AMSI did is it created a single interface that all of the AV EDR vendors had to build to, because if they just hook into AMSI, they don't have to worry about the collection piece because that data is just sent over to them. Same with the application developers, don't have to worry about what AV or EDR is being used on the back end, as long as they provide the data in the correct way to AMSI. So it kind of decoupled those the collection piece from the detection, made it a lot easier for both application developers to create more secure code, as well as EDR and AV vendors to consume that data. But in a typical machine, it's being sent over to Defender for services unless they've installed some other third-party AV.
Jake, we got a question.
Okay.
Is it possible to run AMSI bypasses in PowerShell without being in an interactive shell?
Can you clarify what you mean by an interactive shell? Because yes, you can run it from, like, if you're using like C# to host your PowerShell instance, like in the case of what was it? No PowerShell is like one of them, where they're not running in PowerShell.exe. So PowerShell is actually hosted in the system.automation.management.dll. That is the entirety of PowerShell. You don't actually need PowerShell.exe. If you're running through that method, yeah, you can totally run an AMSI bypass in PowerShell through system.automation.management.dll. AMSI gets loaded when you do that. So we'll talk about how you'd obfuscate your AMSI bypass to do that. Or it's become a lot more popular, like with things like Donut and other C# payloads, to just run the AMSI bypass in another programming language to patch AMSI prior to loading in your PowerShell, and then AMSI doesn't matter at that point.
We have another question. When was AMSI introduced? Any specific Windows version? I do know it was introduced in PowerShell 5. I don't know when it was introduced into Windows.
Yeah, I'm not positive on that. So PowerShell version 5 is when it was introduced, when they published that, but I'm not sure which version of Windows that was at the time. So a lot of systems, even when they publish it for PowerShell version 5, a lot of the systems were still prepackaged with PowerShell version 2. And so PowerShell version 2 has none of the security features. It doesn't have script block logging. It doesn't have module logging. It doesn't have anything, which was in Windows 7. So actually, it was I can't tell you the exact Windows build. It was sometime in the lifespan of Windows 7, though, when PowerShell version 5 was introduced. So
Barrett said 2015.
Yeah, so an interesting note about like the CLR hooks, because like I said, as of .NET 4.8, the CLR is also integrated with AMSI. Is if you go read the open source .NET project for .NET Core, there's a note in there that says, here we'll invoke like into AMSI scan buffer that says basically this should only be done when the assembly is loaded from in memory, because it assumes that something else is instrumented to scan files on disk. That's interested from the standpoint that I'm stealing my own thunder here a little bit. There's actually two different detection engines in a lot of EDRs and AVs. A lot of them have a separate detection database for on-disk scanning from in-memory scanning. And a lot of times for .NET stuff, the on-disk scanning is much less robust than the in-memory scanning, because attackers are usually trying to operate in memory. So all their detections are built for in-memory detection. So if you're not too worried about being detected by dropping something to disk, you can write your assemblies to disk and load them from disk, and you'll have a lot less detection problems usually. Alternatively, there's also some projects like Sharp Transacted Load that have been published that actually abuse this in a way that like basically tricks the system into thinking that the assembly is being ran from disk, even though it's being ran in memory. And yes, there will be a recording of this session sent out to everyone. We got a question asking if the recording will be sent out. So after talking through all of this, we have the problem of human versus machine analysis, as we were talking about, like in the funnel. Like the detection step is largely automated, and using automated obfuscation tools can also help us produce stuff. And basically, we're having machine like kind of outsmart machine at that point. But heavily obfuscated code will immediately jump out to a human analyst as suspicious. So it kind of pits like our logical evasion against our classification evasion. If you're familiar with the evader classification designators. So if you're like a SOC analyst that's trying to look through hundreds of logs a day and lots of that's PowerShell, and you see this pop up, I think a lot of us here would kind of recognize this immediately as a Empire payload. But if you're a new SOC analyst and you hadn't seen it before, it doesn't necessarily immediately jump out to you as malicious. Whereas if you see this in a log, there's really no reason for what's the word I'm looking for? I'm totally blanking on, like a non-malicious code to look like this. Like a standard piece of code, there's no reason for it to be obfuscated like this. So it would just immediately jump out to you as like there's something off here. Like they wouldn't necessarily know it's malicious, or say like, oh, for sure this is something really bad, but it's automatically perceived as off. So now we get into the fun part where we're actually going to go do some obfuscation of code and go over that. So we're going to obfuscate our static signatures. So as I mentioned, code is evaluated when it's readable by the scripting engine or the CLR. So this also applies for assemblies. Technically, the assemblies have to be readable by the CLR when you load them in, or they wouldn't be able to be loaded by the CLR in the first place. So you can't necessarily encrypt your assembly and load it. You have to decrypt it and then load it. And so there's some issues there, but it's kind of like I said at the beginning of this class, like all these principles are the same throughout .NET stuff. So when we pass in base64 encoded PowerShell, that can't be read by the compiler. So when it gets sent over to AMSI, it will be undone from that base64 encoded code to write host test. But if we do some concatenation of a string, write host te plus st does not become write host test in the logs, because that is readable by the compiler. So this is what allows us to still be able to obfuscate a lot of our code against AMSI and other means of static detection at runtime, is the fact that as long as we can make it readable by the machine, then it can't necessarily be undone further from there by automated tools. So what we can do is we can start modifying our hash, modify like byte strings, and modify like the structure of our code. Those are kind of the three different pieces, like categories of obfuscation that we can implement. So the modifying the hash, as we said, is literally change anything. That can be like randomized capitalization, which we'll show in a second, adding extra spaces to your code, like literally anything changes the hash. And you'll actually find that on certain detections that they really are that fragile. And so so it's best practice to change our hash, but not necessarily the most effective. In PowerShell ignores capitalization. So it really doesn't matter what we do. So it all comes out the same when you use randomized capitalization in PowerShell. But AMSI ignores capitalization, so it's not that effective. But change your hash to best practice. C# doesn't have the same flexibility, but changing the capitalization can kind of change the identification of variables that are being scanned for. And it modifies the hash. So you just have to be a little more intentional in the way you change your capitalization with C#, but you can go randomize like the capitalization of a variable. You just have to make sure that propagates throughout your code and is the same throughout the code, rather than being able to randomize the variable capitalization throughout. So when we modify byte strings, there's a lot available here. We can change the variable of our names. We can concatenate things. We can use variable insertion. We can potentially change the order of execution. That's one I like to use a lot. For C#, changing the variable type, like from a list versus an array, can also create some changes in our byte strings that break detections. So it looks like there's some chat going on here. So do we have any questions, or is it just kind of side chat?
It was like mostly side chat stuff,
Okay.
Jake. There was one that just came, and I didn't have a chance to read it yet. It's more just a comment.
Okay. So PowerShell recognizes the $ as a special character in a string. Well, specifically in a double quoted string. A single quoted string will not is a literal string in PowerShell, so it will not allow you to do this variable insertion. But the double quotes allow you to do this variable insertion piece. So PowerShell recognizes, like I said, that $ and allows us to break up things that would otherwise be detected. So like in this example here, I'm going to go ahead and just get my PowerShell set up so that we can try a couple of these.
Yeah, and if you have a box, this is a good follow-on point, everyone. So.
Why is it not letting me zoom in? Okay. Is that readable for people?
Yeah, it's good from my end.
Okay. So there's a couple of different words and stuff that you can use, but I like to use AMSI context as like a default trigger. Oh, I have, from some testing I was doing earlier, I have Defender turned off. So if you're not aware on how to turn on and off your real-time protection, which is AMSI, you can go down to your dropdown and look for security and open that, and then go to your virus and threat protection, manage your settings, and as you can see, my real-time protection is off. Something to note when you're doing testing is in modern Windows, so Windows 10 and 11, it's actually been built to automatically turn real-time protection on after a set amount of time to try and prevent people from disabling this and just leaving it off permanently. So now that we have real-time protection on, we'll go open PowerShell again. So for testing, it's nice to have like a known string that's going to be malicious and get flagged, so you can make sure that like all your systems are working. So AMSI context is a string that I tend to use as my default for testing if something's getting detected. So as you can see, that it doesn't allow us to write out AMSI context because that's malicious. So if we do var1 and we just break this up into AMSI, and then we do, oh, whoops, I did this backwards. So one thing to keep in mind when you're doing variable insertion, once you put that $sign to like there's a space or something in your string, it'll treat the entire thing as the variable name after that. So you actually have to do the back half in your first variable, not the first half. So if we do that, and then we do, we don't actually even have to put it into var2. We can just we could just do it this way on the command line like we were. Like that, and then it prints out. That's because once variables are put into the into memory, like a variable has been ran, AMSI makes the assumption that anything was checked for being malicious. It doesn't actually check what the contents of variables are, and unless you try to execute them as a script block in and of themselves. So we can load data into variables, and none of the logs in PowerShell, script block logging or anything like that, will actually see the data in the variable. And like load it in, and then once it's in memory within like a PowerShell context, we can then use that variable without having to worry about it being flagged. So we'll go back to our slides now. So variable insertion can also be done in C#, as of C# or as of C#6. But if you're writing any C#6 is pretty old at this point, so you're almost certainly using C#6 or newer. One interesting thing is if you use a decompiler to examine your file, this will look the same as doing concatenation, but does produce a different hash. I don't know why. It's just like a weird, like if you use IL-spy or something like that, it's just a weird thing that it does. But you can do variable insertion in C#. I've used it. It's pretty effective. Format string is another way of kind of doing data insertion or variable insertion. And so it's pretty useful. This is probably one that you've seen a lot. It's one that like Invoke obfuscation or some traditional PowerShell obfuscation tools use pretty heavily because it allows for some pretty convoluted ways of building strings and stuff like that. Because you can basically the order that the variables appear in the string don't necessarily have to align with the order that they're being inserted. They just have to align with the order that the list is passed into. So like if this was a 2, we could put 3 words over here, and it would insert the second word, or actually the third one technically starts at 0. The third word into there, even though there was like 2 ahead of it. So it allows for some like really convoluted ways of like packing your strings and that kind of stuff. So it's pretty popular for an obfuscation tool. C# also has format string. An interesting note, like I said, that I put in here is so for the variable insertion looks like concatenation if you use like IL-spy to decompile it. Format string looks like variable insertion if you attempt to decompile it. Like, I don't know, it doesn't really mean that much, but it's just kind of an interesting quirk for how when you decompile .NET assemblies that they don't necessarily fully come out properly. They do come out a little weird. So encrypted strings are kind of like cheat mode for PowerShell because the way PowerShell and AMSI evaluate stuff is, as we were talking about, they do an aggregate risk. So they start scanning your script block and identify different pieces of code that have to be executed together to form like your malicious detection. As they find like download string, they'll increase the risk level of the detection. And And then when they see another thing, they increase it higher. And if you get over a certain threshold, which we'll talk about later, it flags it as malicious and therefore blocks it. But it's doing that per script block, even though it will follow code down. So like if we break, when we use encrypted strings, we will still have to decrypt the second half of your block or whatever, however much of your block to actually execute it, and will go unencrypted into the logs at some point. But because you are forcefully separating them in the code that AMSI is looking at, or the AV is looking at, it'll scan it, not see any of like half of your malicious code, and not get your aggregate risk level high enough. And it'll scan the second half of the block that gets past the other information later on. And that won't trigger it by itself either. And so it allows both script blocks to execute, because even though if they were in a single script block together, they would not be allowed to execute. So encrypted strings is like easy cheat mode for getting PowerShell stuff past AV. So we're talking about like these script blocks and syntax trees and that kind of stuff. They represent source code in both compiled and interpreter language. They create a tree-like representation or a command. So this syntax tree over here is this what this code looks like. And so when I'm talking about breaking up script blocks, at the very top in a, do we have a PowerShell one? Yeah, so in a PowerShell one, your top level AST is a script block AST. When we use encrypted strings, we're creating a forceful separation between those syntax trees that allows for the code to be evaluated separately. So instead of having a single script block AST that is being evaluated, you have two separate ones. That makes it harder for AV to identify it. This gets really kind of funky and abstract, hence the name abstract syntax trees, but just know they're a way of representing code as like different pieces and allows you to go all the way down. And so like modifying different pieces of the code to break up how our syntax tree looks allows us to create some different evasion opportunities. So that's so that was a lot in a very short amount of time. So does anyone have any questions? Okay, cool.
You lost everybody.
So we'll also walk through this in an exercise when we do this, but kind of a framework to work from for building your obfuscation is to start off by breaking the code into pieces. So like if we have a really long PowerShell script, we can break it into like thirds and run it by itself and see if that gets detected. Run the second third by itself, and then run the last one by itself. If none of those get detected, we can build the blocks into larger pieces until something does get detected. And then once you get your detection, you can start trying to identify what the code is being done there. So you can change if you do. So there's some examples in here where there may not be a single piece of code by itself that causes a trigger, but the code altogether does. And so like if you just change like the structure of the code so that something executes first instead of last, because there's quite a few pieces that are put into scripts that are ran in a specific order because it makes sense to us as humans, but they don't actually have to be in that order from a computer standpoint. So reordering those things can break up code if you can't find like a specific detection. So like another way we can break up code is to use like staged versus stageless payloads. Scripts and assemblies are typically evaluated individually as they're loaded. So using a staged method can make it a little easier to get past AVs, because if you try to run the whole thing all together, there's a lot more stuff that's malicious. And it's, like I said, they typically examine them each piece individually and doesn't necessarily correlate them together, although that's changing in a lot of EDRs and that kind of stuff. The trade-off is that we have increased network traffic, but we have less malicious code to be identified. So what you'll see nowadays is a very basic download. Is kind of so like Empire still uses like a essentially a 3-stage handshake method. That's become a lot less common. What you'll see nowadays instead is like a 2-stage method where they basically just have a download cradle that's simply there to like disable AMSI or like ETW or whatever, and then download the rest of the payload. Since that like single piece of code is a little easier to obfuscate. So now we're going to get into exercise 2, which is doing some PowerShell obfuscation. I'm going to take, we are going to take this time to give like a 5-minute break in case anyone needs to go to the bathroom. Anthony, if you can tell me, can you help me out and start the...
Yeah, I'll start a timer, and we can also use this time to answer questions.
Yeah, to answer questions. And feel free to, if there's something you have a question about that we haven't necessarily talked about at this point, feel free to ask it. So if you're brand new to this, a lot of it's going to be, first, I would start off with getting a basic understanding of like a programming language. Like it doesn't matter which one. Like it doesn't matter if you go learn VBA or PowerShell or C or whatever, just some kind of programming language that gives you an idea of like how code is structured. And what that looks like is really helpful. So feel free to, I mean, you can go learn Raptor, which I'm sure no one here has heard of Raptor, but it's a really funky language that was designed for computer science courses. It was used for like 3 years and then they kind of abandoned it. Python is another good option. But that's kind of where I would start if as a newbie is I would go learn some basic coding principles, and then a lot of this will make way more sense to you. And then we got another question that said, is there any point where the number of AST nodes becomes in and of itself suspicious compared to the relative length of the code? I'm not aware of anything that would identify that as suspicious. I'm sure that
it's very
someone...
common in Windows. It's how essentially it's how .NET manages everything is with ASTs. Yeah, so going back to the newbie question, is yeah, someone actually put in a pretty good recommendation of PowerShell, and then scripting how payloads work, and then how EDR works, and then AMSI bypasses. That's probably a good flow. But also like just recognize that like a lot of this stuff is jumping into the deep end of the pool in the sense that like if you try to get a strong understanding of everything all at once, it's going to feel insurmountable. So just kind of pick something that interests you and start learning about that, and you'll naturally learn the other pieces as you try to research that. Somebody did ask, can we review once again how AMSI works?
Yeah. So AMSI is interfaced with actually. Oh, I don't have it up. Anthony, do you know if you have the link to the compiled script code block in PowerShell? No, we won't worry about it. I'll just talk through it.
Okay.
So AMSI works by like in PowerShell specifically, if you look at the source code, which we're not going to do because it's not that relevant, but basically when it goes to compile, when you build a script block, it's held in memory. When you call it the first time, PowerShell compiles it with the just-in-time compiler. This is how all .NET languages work. When you load an assembly, it's not compiled into machine code until you call it for the first time. So at that time in PowerShell, when it gets called to be compiled, right before it actually compiles the code, it will call the AMSI interface and it sends everything over in a string, which is another interesting limitation about AMSI is regardless of whether or not it's sending a .NET assembly, an EXE, a PowerShell script, everything is sent over as a string. So it's just doing like bytecode matching or bytecode hashing or byte hashing to do the identification of the code. It cannot do it in any kind of, AMSI itself cannot do anything in a dynamic method because everything is sent over as a string. So at that time, right before it gets compiled, which means that things like encryption have to have been undone, it gets sent over to memory. That other piece about like it being called when the script block is compiled ensures that if you do something like that encrypted strings thing I talked about, that second level script block is also still scanned, that not just the first script block in execution is scanned.
We got a follow-up question. Is AMSI the main thing preventing malicious scripts from running?
In a modern Windows environment, yes. If you're doing something super sketchy, like PowerShell trying to touch LSASS, then Defender does have some dynamic behavior detections built in nowadays that may have schwacked you. There's also Defender also does some. We actually have a exercise of testing, I think, in here. If I remember, I don't think I removed it. Does some in-memory scanning for strings. So like if you disable AMSI and then go run invoke mimikatz, it will allow the script to run for a few seconds, and then it will kill it off either because of the behavior or because it detect. But it could theoretically be because of the behavior, but I doubt that because if you change it from invoke mimikatz to like invoke dogs or whatever, after AMSI's been disabled, Defender will no longer kill it. So my suspicion is that it's actually scanning for strings in memory that are known to be malicious, like the word mimikatz and that kind of stuff, and it finds it in memory regardless of the reason. It'll kill it off. That's also further buffered by the fact that at one point Anthony and I almost got locked out of an entire class of materials because Defender saw notes in our slides about some code that we were using as an example and determined that the code, since it was in memory, like while we were trying to save it, it determined that the code it saw was malicious and like wouldn't allow us to open the file or save it because it was like trying to kill off the process because it saw the malicious words in memory.
So it'll put malicious text in the PowerPoint slides because it will flag it as it tries to do auto saving. Jake, probably about time to go through the next one. I know some people are asking, Microsoft has a Windows Dev VM that some people have downloaded to do the exercises.
Yeah, so the easiest way is Microsoft publishes a developer VM that comes preloaded with Visual Studio on it. It's really nice. Another thing that you can for even more like complicated testing if you want for like a home lab is they actually have it's not EC2 because that's the Amazon thing, that's what I always want to call it, but you can actually go sign up for like a Windows 365 developer license. It's good for 90 days. And all you have to do to get it extended to the next 90 days is have used the account recently. And they give you 25 accounts that get access to like Office 365 and Outlook and Azure Active Directory. And so you can go incorporate that into your local labs. Yeah. And then I got one more question.
There was one about the length size for a string in AMSI. Is it limited?
I'm not aware of one. I would assume that there is one because at some point variable size is going to be a problem, but I haven't found anything that has a problem with it. Okay, so we're gonna go walk through obfuscating some of these. Oh, my machine turned off. That's fun.
Your dev VM, by the way, if you keep it up for a really long time and the license expires, randomly turns off. So heads up to everybody if you plan on keeping your dev VM for a long time. I thought the Microsoft activation scripts don't work anymore on those dev VMs. They are special built now that you can't reactivate them.
You did use
all of our personal ranges have been like migrated over to like actual boxes. So
you did used to be able to trick the expiration, like as recent as last year, trick the expiration on the box by just setting the local date back to when it was still valid.
someone said you can rearm them 3 times, but you can't use a legit key to convert it to a full build. That's what it was. Thank you.
Okay.
Yeah, because it's the Windows 11 Enterprise Evaluation. It's like a special build just for this.
Okay, so let me go open ISE. So we'll walk through these real quick. This is from me testing, so it's already. Wait, this looks like the wrong exercise. I apologize. I might have grabbed the wrong exercise.
Those look like the right ones for the numbering, at least.
Oh, this was just to have them obfuscate the code. That's right. This was not breaking the signatures yet.
Yep.
Okay. So just some fun stuff to do with these is like an easy way to change these is most of when you see new object and that kind of thing, most of them can be changed from a system Windows form or from that new object directly to an assembly like this. So this should still work if we run it. Sure. Oh, that's right. So you have to run the, so keep this, you have to, so if you get a error about being able to run scripts, I saw someone posted it in here a little bit earlier.
They only posted it to us. I'll post
it to everyone. So
okay.
you can use, if you get an error about being able to run scripts, just set this, set execution policy is not considered a security boundary by, I forgot this. So let's see. Yeah, so it loaded and it ran. I just got, oh, my window's in the way. But you can see the pop-up right here. It says you'll be automatically logged off. So you could do that. We could, so one thing to note is that these are pretty hard to obfuscate when you're using properties of an object. Those you still kind of have to use. So those names themselves are being obfuscated or being detected, they are a little hard to use, but there are some things like you can use backticks in these actually. If you wrap them like this, usually this should still work. No, it did not like that. Oh no, you do this.
Some people said this doesn't match their sample one. Jake.
Okay, that's what I thought. Okay. That's what I thought. Okay. Yeah.
Yeah, it should
be. I think I opened the wrong. I think this is from our other class.
Yes. So it should be I'm the assembly.get type.
Yeah, I'm in the other class. I'm in the evasion class.
I was like, this doesn't make any sense.
my ISE defaulted to the other class. So let's see. There we go. Okay, here we go. So sorry about that. So yeah, so we run this and we should get an error about it being malicious. So one thing to note when you're doing these kinds of tests is that Windows does maintain an aggregate level of risk, and if you test things too many times, you may get to a point where the box is just like, I don't care what you're doing. PowerShell is malicious now. And it'll be that way for like an hour or two. So one thing you can do when testing in a VM is create a snapshot before the bot while the box is an okay level. And then do your testing. If you hit that point, go ahead and like revert it. And a good way to notice that is when you start getting frustrated, go back and test something that was working. And if it's not working anymore, then that's probably what happened. Because I can tell you, like, there's been several times where I've spent like an hour trying to obfuscate something, and or like I thought I got it working. I went to go show like Anthony. I'm like, what the hell? Like, this was working, 10 minutes ago. Why is it not working anymore? It's because I triggered the box from having like too many like attempts at running malicious scripts, so it was just flagging everything. So you just gotta let it
you out.
off. Yeah,
that's what it's doing.
So getting back to this now that we have our things in here. So if we go and try and run like these one at a time. So I'm actually going to run it in another PowerShell window, just because this is a AMSI bypass. So if we get both strings to run individually, we'll have turned AMSI off in our session, and like we won't be able to test them together. So you'll have to restart your session before you do it. So that brings up a good note that AMSI is loaded per session, or like per process. So if you disable AMSI and then like inject into another process or spawn a child process or those kinds of things, AMSI is not disabled in the new process because the AMSI DLL is still loaded again, and the patching is only done in memory. You're not actually touching the DLL on disk. So that's a good thing to keep in mind, that like if you go to migrate somewhere else, then you're gonna have to disable AMSI again.
Jake, on that note, did somebody ask, is that aggregate level of risk attached to the process then?
No, it appears so. All of it, like I will say, I can't definitively say no. All of this is unpublished. Yeah, all of this is unpublished and undocumented, and is purely based on my experience with stuff. But in my experience, it is not attached to the process; it is attached to the box. So it used to be that you could restart the box and it would just go back to where it was. But in the last year or two, it's actually been persistent across system restarts too. So.
The random things you find out when testing.
I've asked some Microsoft people for that kind of information before, and they just laughed at me. So
you mean they won't share how AMSI works under the hood?
Yeah. Okay, so having done this a bunch of times, I know that the piece that we're looking for in this specific line is that AMSI is a known trigger. So anything like AMSI utils, AMSI context, AMSI like any plus anything basically will get you a trigger. So if we break up AMSI, this line of code will now run. And so now we, as we mentioned, we break things up into pieces. Now we'll try and see if we can get the second line of code to run. And as we can see, it's flagged as malicious again, but we also know that there's this AMSI init failed in here, which as I just said, the AMSI is probably what's triggering it. So we'll go ahead and concatenate that, and we'll see if it runs. So it does run. So now in this one, like I said, do it in another window because this is an AMSI bypass. So now, like if I run AMSI context, it'll no longer be flagged as malicious. So before we close out the window, let's go ahead and put this.
Jake, somebody asked if you can make it a little bigger.
Yeah, I will do that. So I'm just making this match what we did in the window, which I'll bring up in a second. So let me see. Is that good now?
That looks good here. Brett, does that work for you?
Okay, cool. So I just made like let me see if I can shrink this a little bit. So I just made like the changes we did in here to get it past match up here. Oh, actually, it's off by one here. We broke up the AMSI specifically. So, we'll close this out and we try running it again, or we'll close out this PowerShell window because we can't really use it for testing anymore. If we run it in here, we'll see that even though those two lines ran by themselves, they're still being flagged as malicious now when we run them together. So I know that that's because of a couple of things. Because like I said, I've done this a lot of times. These get fields together are, it really doesn't like those. So like I said, if you use backticks in this, you can actually break that up by wrapping them in a double quote like this. And it has to be double quotes, not single quotes. But the code will still execute, like just to show real quick. And this, I'm just showing it in the other window because this is not enough to get to run. It'll still be considered malicious. So we run that line and then so even though those backticks are in there, oh, it didn't like that. The backticks are supposed to be escapes in here. Did they change that? I don't think I have to wrap it in these. No, you definitely don't have to do that. Okay, well, we won't do this obfuscation method. I'm drawing a blank on why this isn't working. Maybe it's the single quotes. Maybe I'm misremembering. Nope. Okay, well, we won't worry about that for now because we can break this up. So yeah, it doesn't like
Jake,
these together.
it's because you had it on the T. You can't put it on the T.
Oh, right, because of that's the tab function, right? Yep, it's because I had a good catch. Whoever caught that, thank you for reminding me. Yeah, it's the tab.
Yeah, a couple people caught it. I'm sitting here looking at it too. I'm like, why is this? Thank you.
There, thank you guys.
Live demos.
Yeah, so,
what do you expect?
Oh, that's because I still have single quotes here.
Sacrifice the demo gods.
Yeah, okay. There we go. So thank you guys. I totally forgot that the backtick T is the tab escape. Not paying attention. So if we break these up, that's probably the quickest way, but I also know that oh, I just almost did it again. So we try this. I don't think it's gonna run. Yeah. So non-public static is actually another one that increases your risk score. A lot of times it won't get flagged in and of itself, but it does increase it. So I like to break it up. And then, like I said, it really doesn't like this true being in here. So a lot of times what I'll do is we will just make this like AS, and then I just add another line because anything can be a one-liner if you add enough semicolons in PowerShell.
I feel like that needs to be a T-shirt or something.
Anything can be a one-liner with enough semicolons. So you put the true in here, and now I think this will run. Let's see if I get lucky. Oh, A is another one. Just do this. There we go. There we go. So it ran that. So it runs now. So yeah, that true is actually the biggest indicator. You do need to break up like one of these get fields. They're also good to break up because although they've caught on to it, it used to be if you did this, you'd prevent that warning script block designator that I mentioned earlier. But now if you start doing string manipulation after a dot like that, it flags it as well. So unfortunately, it doesn't work as well as it used to be. So that's the first example. I'm not going to do all the examples. I am going to do sample 3 just because it's an interesting use case, or like an interesting one to do. So this is internal monologue. Another thing that's good to do just as a best practice is to remove all of these comments. For this one, it doesn't actually matter, but a lot of malicious scripts actually have like keywords in the comments that can trigger things. Most of your C2s will automatically strip out comments for that reason. But if you're running like a script like blind, that's a good way to do things. So if you run this, or not blind, naked, like you have a bunch of stuff. So if we try to run
Jake,
internal monologue,
real quick, somebody said that their defender's screaming at them. What do you do exclusion wise to make it so defender doesn't destroy their folder?
Oh yes, all of these are all in an excluded folder. Yeah,
so under security, you're gonna have to exclude the folder. Otherwise, it will delete it.
I'll show you how to do that real quick. So if you go to Windows Security, and then click on Virus and Threat, you'll go to Virus and Threat Protection Settings. If you go to Manage Settings, scroll all the way down, and there's an Exclusions. Yeah, or someone just dropped the that should work, James, as well. James dropped in like the code that should work. But I usually just do it this way. Sometimes I like using GUI, sometimes I don't. But so like I have a bunch of excluded folders on here. And then I just did exactly what I said not to. So this didn't flag because we ran the AMSI bypass in here. So we have to close ISE and open it again.
Just exclude your entire C drive and you're good to go.
Don't do that because then things break. Or not break, but the tools we like to use, like threat check and stuff, break if you exclude the whole C drive. Also, it doesn't work that way. Like the recursion application of exclusion does not seem to work super consistently in Defender, by the way. Mm-hmm. Like for really large, like, so I tried, that's why a bunch of them were in there. Is like I tried to just exclude my entire downloads folder, and it was still deleting things. If you go like more than like a file or a folder or 2 deep, it'll just start, it won't, like it'll ignore the exclusion and start whacking things again. Okay, so now that we're here, I'll try to run this, and you'll see it gets, oh no, I gotta run I need to fix this box. Just go change the registry key so I don't keep having this problem. So now it says it's malicious. This one is actually, if you don't know what's going on, actually kind of hard to obfuscate. But it's because there's a very specific thing in here that is causing it to be malicious, which is like specifically this challenge line being in the file, or specifically in this location. So like if we remove it, we can try running it, and you'll see it runs. It doesn't actually work properly if you tried to execute the code, but it's getting this to bypass Defender, at least it used to be. I forgot to double check this morning. Should be as easy as just moving this line to the top up here. Yep. So like this is just to show that like they'll identify pieces of code that are unlikely to be changed, and the order that they occur in that are unlikely to be changed by like automated obfuscation tools. So reordering code, because none of these, like if you look at how the code's executing and actually read this, these are all just kind of like quick checks on like how to do some to set certain values at the start of it. None of these actually matter which order they're being executed in. It's just the way that whoever wrote it, and so no one ever changes it. Like even if they go modify like internal monologue or whatever, they never mess with this part because someone wrote it that way. It's just the way it always is. And so when someone was models their new script off of it, they just cut and paste it the same way. So like just changing your structure of your code can be like really, really effective at breaking detections. Because if you leave this the other way, like trying to like obfuscate that like this number over here, or even like I think I tried at one point to try and change like the variable names and like nothing was working. But as soon as I moved this up like 3 lines, then it obfuscates like super easily. So it's just a cool example. The other one is let's see, I'll go ahead and open these just to look at them. Oh, we're not going to walk through it. So this is another one that's pretty quick to do. That new object thing that I was showing. This is actually flagging on the fact that they're using system sockets.tcp client here. This new object, if you change it, so like if we try to run it, it gets flagged as malicious. But if we go ahead and just change this to a TCP client new, actually it might be create for this one. Oh, nope, it is new. Yep, so we change it to a new like this. I think just that. Yeah, so all you have to do is change that to a direct assembly call or direct.net assembly call, and it flags it. Otherwise, like this is actually a script I pulled from someone's blog where they went through like this entire elaborate obfuscation process because they didn't really know what like AMSI was actually flagging on, and so they like did this like super elaborate like math changes and stuff in here to fix all this when really they were just getting flagged on the fact that the new object was being created with this like RC4, or I think they're doing RC4, or no, they're just doing a regular data pool. So like that's like something to keep in mind. Another cool tip to know is, so we've talked about all the script block logging, and PowerShell also has module logging. If you call a .NET assembly directly, you avoid going through module logging. It only logs actual PowerShell modules or scriptlets being called. So if you call .NET assemblies directly, they don't go through module logging. And module logging is actually the most robust form of logging in PowerShell. I've not found a way yet to actually hit a module log obfuscated. All the other ones like script block logging and transcription logging and all those have ways to hit them obfuscated. But the module logging, I've yet to be able to actually hit a module log obfuscated. Okay, cool.
Does anybody have any questions on the exercises or anything? One person said no, so you're
okay.
Good.
Yeah, so exercise 3 was to use threat check. Unfortunately, threat check appears to be broken. It was working when we did the workshop in August, but it appears to be broken now. So we got the question that says, like, if you have like a large power script, do you have like 2 options of either obfuscate the big PowerShell script with these kinds of changes, or do you execute a smaller payload that does the AMSI bypass first and then execute the rest of the script? And yeah, those are kind of those are basically your 2 main options. As you can see, like, especially if you go try to do some of the examples by hand, or go find some other scripts online to analyze. They doing this by hand is super effective for targeted stuff, but it's a ton of overhead. So it's can become very time consuming to do large scripts. The flip side of that, just as a counterpoint to it, is because most C2s and attackers land on boxes, run their bypasses, and then load up their stuff. A lot of the actual implants and other malicious code don't have super robust signatures built against them because they're never actually collected. So like, interestingly enough, it's really hard. Like, it can be very difficult to obfuscate the stage 0 Empire launchers. But if you go use like a stageless Empire code and just go try and run the agent in and of itself, all you have to change is like invoke Empire to like something else, and the code will just run, because the agent itself is not actually super well signatured. It's all of the download cradles that are like really hard, like really well signatured and like really watched. So depending on what you're trying to do, it could actually be easier to like embed a whole agent in the code and then just run it that way, depending on how the code's being used.
Memory's cheap.
Memory is cheap nowadays.
An entire Empire agent is smaller than a crib tab, so
yeah,
that's not saying much. But
Anthony was having an argument with a C developer about like the importance of like how large your payloads are, and Anthony was just like, open your task manager and tell me how big your Chrome process is right now.
30 gigs. Okay, my point exactly.
Yeah. Chrome already has all the memory.
That's a good one. Someone said you need to be careful because Chrome already stole the memory.
And depending on how our time goes, if you guys want me to try and like live obfuscate of how the Empire payload that is sample 4 from the previous exercise, we can try and do it. I just won't promise that I won't resort to using encrypted strings to make it easy. If we run into problems, but I could show you how to use encrypted strings. Yeah, I think we should have time, just because we did schedule this for 3 hours because like that's kind of what the workshop was originally. But since we're not taking like 20
attention spans.
Yeah, and since we're not taking like 20 minutes to do like give you guys time to do the exercise and then having me walk through it, we'll probably run a little shorter than the 3 hours, so we should have time at the end. But the next thing that we're going to talk about is dynamic evasion, which is pretty fun. This is where we're going to actually get into our more of our bypasses and those kinds of things. So what we can do about like dynamic detections is we can try and detect like if we're being ran in a sandbox for like our email delivery use cases. We can look for known hunter or AV processes. So like if we see McAfee running on the box, well, we probably wouldn't care about that one. But if we see CrowdStrike running on a box, like one of their processes, we may just say like this isn't worth our time and like just move on to a different target. Or if you see other things like that. We can change how we're executing. So like we could, if we're trying to do code injection and that gets caught, we could inject in a different way. In modern environments, you should just not inject. It doesn't really work well anymore. It's just way too noisy and way too easy to detect from a behavioral analysis standpoint. But for like our download cradles and stuff like that, we use a different download method. So instead of just using like a TCP socket or just download data, we go pull our payload from OneDrive using like the MS Graph interface. We can also circumvent known choke points. That's kind of, if you guys have ever heard of dynamic invoke versus pinvoke. And actually, I just realized we've been saying pinvoke a lot, and I didn't explain what that is. Pinvoke stands for platform invoke. So the Win32 interfaces are like the underlying API layer for Windows. A lot of programming languages in modern Windows have a means to access those directly. So like when you do, I'm trying to think of a good one. Like when you copy a variable to another variable, like you're actually like marshaling memory and then sending bytes over and all that kind of stuff. Well, PowerShell like does that automatically for you. But if you want to do it by hand, more like you were trying to write C code or something like that, you can use pinvoke to access like the Win32 API marshal call and marshal memory specifically. In fact, that's what we do for some of these AMSI bypasses. Is we'll like see that specific example in a little bit, because it allows us to like copy memory or data into a specific memory location, whereas like because PowerShell is high level, it's obfuscated that away. But pinvoke uses the ntdll .dll. Those are where all of those functions live when you're trying to call the Win32 APIs. And a lot of EDRs nowadays are hooking those that DLL, and so they're putting like a diversion in there. And so when you call those functions in ntdll, they'll look at what the actual call is doing and then either log your data or prevent you from executing it, depending on what they do. Dynamic invoke was a way published by the Wover and that kind of thing to actually like map those Win32 API calls at a lower level to a lower level, like not quite in the kernel, but like in a lower level to avoid the NTDLL calls that were being like hooked by EDRs. So they're just, instead of going through that choke point, they're just going around it and using a different way. It's gets deep into the weeds of how like delegates and stuff work, but it's pretty cool. That is an option, but it involves developing like an entirely new TTP. So the one that we're going to really spend some time talking about is like corrupting the detection process. So we can patch AMSI, we can patch ETW, or for that EDR stuff we were talking about, like we can unhook the DLL itself. So basically, or unhook APIs. You'll hear a lot of talk about unhooking APIs if you're like getting into red teaming or been into it for a little bit. Unhooking APIs sounds a lot fancier, but it's really just patching the patch. So like when we patch AMSI and we patch ETW, that's basically the same thing as unhooking an API. The like code is like exactly the same. It just has a few additional steps to figure out, like to identify like has the hook or has the DLL been hooked, and like where in the memory do I need to patch. But the like fundamental process is just patching a patch. So if you understand how to patch and the AMSI DLL or patch ETW and those kinds of things, you understand how to do like API unhooking. There's a few extra steps involved, but it's really not. It's become like this big buzzword about people being like, I know how to do like how to like patch ETW and AMSI and stuff like that, but I want to learn API unhooking. And they really actually already know how to do it. So the first bypass we're going to talk about is the one we used in that first exercise. This is the is Matt Graber's reflective bypass. He actually published it all the way back in 2016 via a tweet, which is kind of cool. I'm not sure of many other major bypasses that were published via a tweet. So it's 2 lines of code. It's actually, I don't think I have it. Yeah, we'll talk about it in here. So it's using reflection. We're exposing the functions from AMSI within PowerShell itself. So PowerShell is calling AMSI DLL in a C header somewhere. And when it goes to load AMSI, it has this piece of code in here. Let me move the webinar chat window. That says if AMSI init failed, return AMSI utils, AMSI native method, like result not detected. So if that happens, then so basically what happened was there was a design choice made that like when by the coders for PowerShell that if for some reason the AMSI DLL is corrupted, that rather than block all execution of PowerShell, they're just going to let PowerShell execute. So this is changing that AMSI and it failed variable to say false, to say that like we weren't successful in initializing AMSI. So anytime that AMSI is called, it just skips over doing the scan of the code wholesale and just returns and says like I wasn't able to do anything with it. Yeah, so this works because we're loaded into the PowerShell the AMSI is loaded into the PowerShell process at startup. It has the same permission levels as the process the malware is in, or our implant, if you want to use that wording instead of malware. Basically, anytime you load the DLL into memory and attach it to the process, it's loaded at the same permission level as the process itself. So we can reflectively modify our process at will because that's kind of how permissions level works. So it never actually performs the security check because it thinks that it doesn't have an interface to call to. So the second AMSI DLL or AMSI bypass that we're going to look at is patching the AMSI DLL itself in memory. It's more complicated, but it still actually allows AMSI to be called by the process so that the code actually gets sent over to AMSI and returned. It patches, and more importantly, is that the reflective bypass that Matt Graber published is only modifying how PowerShell calls AMSI. It's not actually modifying AMSI itself. Whereas when we do this patch, we're modifying the AMSI memory space, like the DLL, and calling and patching it so that anything in our process that calls that memory space, the AMSI DLL, is affected by that. So in the first one, if you run Matt Graber's bypass and then try to load like a .NET assembly, because we didn't change how the CLR is calling the assembly, we only changed how PowerShell is calling it, you'd still get your .NET assembly flagged, whereas this one will actually make sure that nothing is flagged going forward within your process. So this looks, this is a version of this bypass that I wrote that I based off of Tal Lieberman's presentation at Black Hat and some Turla code that I had found that had been published recently. It's coded slightly differently, but does the same thing that like Rostamouse's bypass does, if you've ever seen that one. So this first part is we use C# to do that pinvoke part that we were talking about earlier. So we're using the kernel 32 APIs to find where get proc address is and get module handle and virtual protect so that we can call them directly. And a thing to note is that when you use add type, you do write to disk. It's very temporary. It goes into the temp folder. If you have sysadmins using add type, like we saw in the example logs, you don't really have to worry about it, but it is something to note that you are hitting disk. And so it's also important to note that you can only pinvoke through PowerShell, or I take that back. There are ways to sort of do pinvoke through PowerShell without calling C#, but it takes like 100 lines of code to do it. So if you look at Empire, some of their modules, a lot of the modules don't use pinvoke directly to avoid calling add type so that they can, because you have to do it through C# if you want to do just like a straight pinvoke. They do it through like a reflective type builder that is possible to do, and it makes sense to do in the modules because at that point you're not really concerned about how long your script is, but it's very impractical to do as part of an initial payload because it's, like I said, it's like several hundred lines of code, so it's not very practical.
Jake, we do have a question. Can Defender, AV, or EDR detect that you've modified the AMSI DLL in memory and mark that as suspicious?
So short answer is yes. That's actually a new technique that they are starting to implement. There's a couple of different ways. As Neil said, the ER can hook via the driver. I think there's been talk that what Defender is going to do is basically have like a hash of what AMSI should look like, and if it detects that that hash doesn't match anymore, like it's going to periodically scan where AMSI's been loaded, and if it doesn't match anymore, it's just going to reload AMSI so that the patch isn't permanent. There's another, Avast does something that's a little beyond me in terms of how it maps memories, but basically it like loads it. It uses Avast to load it as an into an admin space, and then instead of attaching the DLL directly, it's using a mapping so that so the process knows how to call where it is in the admin space, and that prevents you from being able to patch it directly. Is another thing that we've seen. It's like the only thing that Avast does well, but otherwise it's like overly aggressive, but it's like a really interesting thing that we spent some time after a class trying to figure out what exactly was going on. But it's pretty interesting. So this second part of the memory or of the bypass is getting the handle to where the AMSI DLL call is, and then setting the memory space to be writable, because when it's loaded in, it's initially set to be read-only. But again, because it's in our process space that we can control, we set it back to be able to read-write. And then we go ahead. And this last step is patching it so that we will always return always return an AMSI results not detected. So cool. So we're going to go run a quick exercise here. Just showing that piece that we were talking about of how the first bypass will not cause, will allow us to write like malicious PowerShell scripts, but seatbelt will still get flagged while the other stuff will not. So we'll go to exercise 4. And if you go ahead and open these in ISE, they should be obfuscated so that they will just run for you guys to make this a little easier, but we'll see how that goes. Oh, this was using SharpHire. I think I have both in there. Let's see. Yeah, there's SharpHire and seatbelt. So you do need to, if you're going to use the seatbelt thing, you do need to update this path to match wherever you have like SharpHire or seatbelt, whichever payload you want to use to load in the system. So fingers crossed for the demo gods. Let's double check that I don't already have AMSI disabled. Nope, okay. Okay, so now we can check and make sure that AMSI is disabled. Oh, I think I moved. We'll see what happens with this one. Yeah, so so you'll get this error about could not load file or assembly anonymously hosted. It's actually kind of interesting. It doesn't say when the assembly is blocked because it was flagged by AMSI, but AMSI is not working in PowerShell. You'll get this error. It doesn't say that it was blocked because it was malicious. So now if we close, actually we shouldn't need to close it. If we just go patch, if we go run AMSI bypass 2, pray that this works. So that ran. Now if we go execute it, it should run. Fingers crossed. Oh, well, I apparently screwed up this call. But as you can see, we didn't get the error about the assembly being loaded, so it did load the assembly successfully versus being blocked like it was the first time.
Someone asked, can you patch AMSI and run malicious code in a one-liner?
Yes, so that's how Empire works. The only thing you have to contend with is that the AMSI bypasses are in and of themselves considered malicious. So you have to obfuscate them to get past it. And anything within that script block, within that one liner, will be scanned. So even if it's occurring after your code, like your bypass code, because of the way PowerShell does its scanning for script blocks, anything in that one liner will be scanned by PowerShell. But anything loaded subsequently after that will not be scanned. Any script block that's built after that. So that's where like the encrypted strings thing can be really useful, because you'd have it as an encrypted string. It reads that encrypted string as the only thing in the script block. The AMSI bypass will have been executed when you undo the encrypted string and call the script block from the encrypted string. AMSI has already been bypassed for you, so you don't have to worry about obfuscating the encrypted string at that point. Hopefully that answered your question. Maybe.
Unless they're still typing.
Oh, and Anthony, have you been checking the webinar page?
Yep.
Okay, or the Discord? So someone said their seatbelt ran without patching. So I try my best to have something that will always be flagged as malicious. Microsoft sometimes changes their detections and updates them and breaks detections for certain things. Especially, I would be surprised if it happened for seatbelt. But especially they'll sometimes implement stuff and realize it's too aggressive and unwind it. And so if seatbelt's not being detected, I apologize. Don't think I have a good way to share like the SharpIR assembly. Oh, someone said they were leaving. I don't think I have a good way to send you guys a malicious assembly that's not going to cause everything to freak out. So the SharpIR assembly is definitely flagged as malicious. I thought the seatbelt one was. Let me try with my stuff and see. Let's try this again.
You should be able to right click and open up a PowerShell window in that folder.
Yeah, I wanted to open the ISE to see.
Lee, that requires me to log in with my Twitter. I don't know how I feel about that one.
What happened?
It was just showing a website that allows you to upload things, but you have to log in with your Twitter, so I don't know how I feel about it.
Oh, yeah, it looks like the assembly did load. Okay. They changed their detections. I apologize. I should have just included SharpIR, but SharpIR is like a large payload, so I was trying to avoid sending you guys large files. Apologize for that, guys.
Any other questions on this exercise, guys? Otherwise, we'll move on to the next one. Everybody can hear my kids.
Yeah, so that's a so like I said, basically we already talked about this, that we can patch it because it's loaded into our process, and so we have full control of what we can do. It's kind of one of the main failures of how most AVs operate nowadays, which is a semi-intentional functionality of what Windows did back in the beginning of the 2000s. So the reason all this stuff is loaded into user land where it can be easily modified is because Microsoft has prohibited the injection or hooking of kernel functions because it was causing massive instability issues in Windows. That's one of the reasons why like the blue screen of death was so prevalent in like Windows XP and like early 2000s version of Windows, was because everything like admin level processes were allowed to inject into like the kernel mode, like inject kernel mode hooks and stuff like that. And so Microsoft just said, like, we're done with this. It's causing too many problems. AV providers, like, you're required to only have user land hooks now. But as a result, that means that the hooks and investigations of EDR are vulnerable to being attacked, at least by admins. You know, like a lot of EDRs are running at an admin level, so basic user can't mess with them. But if you get to an admin level, then you can mess with it as well, because they're all in user land. There has been discussions by Microsoft to reopen access to the kernel level calls and allow for some injection there on a limited basis. But as of yet, they have not done that. So we'll see what the future holds, but there's growing calls for them to reopen that up based on how modern threat actors are able to constantly modify the EDR implementations directly and manipulate them. So AMSI trigger is a tool to identify malicious strings and PowerShell files. It makes calls using the AMSI scan buffer line by line, and looks for an AMSI result detected return in the response code. It's a pretty useful tool. This one does still work, so we can do this exercise. So we'll go look at launcher.ps1 from exercise 4 and look at the lines that are getting flagged. Window. So we're gonna go run AMSI trigger. So if you just open your stuff in the terminal, we want to go ahead and just double check that our AMSI is working. And so now we can go ahead and run AMSI trigger. So we'll go ahead and run AMSI trigger. And then to run it, you're just going to attack I and then provide it the file. I have the launcher.ps1 in here, so I can just go ahead and scan it. Otherwise, you can provide the absolute path. So as we can see, it's flagging a couple of blocks. So each plus sign here is a section where the code is getting flagged, like a chunk of code that it broke up is getting flagged. So we have this split across the AMSI utils, and then this reference get field. So this is the Graber bypass that we used at the beginning. I'll open the payload in a second so we can look at it a little more. Or actually, I'll just go ahead and do that. This is actually an Empire payload that has our bypasses in line, as I was being asked about earlier. So it's not the most readable, unfortunately. Is it broken line or is this?
Can you go full screen? That might help a little bit too.
Oh yeah, good call. Yeah, so this is still in here as a one-liner. It's part of the reason that it's so difficult to read. But we're getting our sections identified as this AMSI. So our AMSI bypass, this one down here is actually an ETW bypass. It's getting flagged. We can see the systems diagnostics event provider get field. There's something in here that it doesn't like. Probably most likely this management.automation.tracing piece, or this get value like null thing. Would be my guess. The other section is is quite a large code section here. From experience, I know that this is actually flagging on the RC4 encryption. And so we can go ahead and look at these. I will say that AMSI trigger is not perfect in giving you sections of code. So like if we go just grab like, let's see if I can grab the section that it grabbed for the utils. Like, so it tells you it's obviously not valid code, but if the code's invalid, it's not really relevant to getting flagged because PowerShell will block it before it gets executed. But it's like it gave us that section, and if we try to run it, you see it still ran it because it didn't get the whole thing. So usually you want to grab the whole like command that's associated with. So like obviously if we grab these two pieces here, then it'll flag it as malicious and tell us we're not allowed to do that. Same with this system diagnostics thing. Like we can try. So yeah, it looks like it did actually grab the whole thing here. So we can see if it executes. So you're gonna have to go test some of it by hand to see if it actually gets flagged as malicious. But even if it doesn't, when you run that sample, so again, that one did get blocked. And then if we look at the last code piece, so it has this default networks. So where is that? The default network credentials, is that where it started? Yeah. So it's starting from this line all the way down to about here, it looks like, if I remember correctly. Oh, no, it has the whole thing here. Yep. So that also gets flagged as malicious if we grab the whole thing. So now we know like the kind of 3 areas of code that are causing us problems, and we could start kind of moving things around. I like to kind of, since we have time and we were talking about doing this earlier for a Empire payload, I kind of like to go ahead and pull out all of my bypasses first and deal with the agent and try so that we can try and get the agent past it by itself first. So we'll go ahead and remove this and just go put it over in here by itself. Because we kind of know the process to evaluate those bypasses, or at least I do from having done it a bunch of times. So now we'd go and move things around. So like we could, it's like, again, I was talking about like moving some pieces around that are not necessarily like position dependent. So like this tnews.php headers add user thing, that can actually be done anytime prior to, oh, my VM shut down on me. That's annoying. Good news is the ISE will auto backup for us. Apologize for that, guys. Does anyone have any questions while we're waiting for this to start up? Cool. And we're right back where we started. So let me full screen again. So as I was saying, like this isn't actually, doesn't really matter until we actually call this download data command here. So it could be anywhere in our script. So we can go ahead and move it up here and close it out, or and go ahead and try and run it. It's probably going to be malicious, but it'll auto save for us. Oh, because of the stupid. Okay, so if we go and try and run it, we'll still get flagged as malicious. We could try and go ahead and run like our AMSI trigger again and see if that causes any different output. Yeah, and see, it kind of like, we do know now that this T news piece is not really a part of what's causing our trigger and our detections. So what we could, another way to do this now would be to start breaking it up and see like where do we shrink it down that AMSI, the AMSI trigger no longer provides anything. Like I said, I kind of know from experience that it's actually this RC4 encryption piece right here. So like if we go ahead and like remove this and run it, you'll see that it just goes ahead and run. It's actually to the point that it can tell that like you're not doing proper RC4 encryption. Like if you make this a 255 instead of a 256, it'll actually happily let you run it because it knows that like it's not valid RC4 encryption. Oh no, it didn't work. It usually does allow you to. That usually does work. Okay. They must have updated their definitions. But so this RC4 encryption is like really hard to obfuscate. So I usually fall back to using the encrypted strings piece, or you can run really heavy like whatchamacallit, what's the word I'm looking for? Like automated obfuscation, like use invoke obfuscation and run a bunch of stuff against it. But it's pretty process intensive. We can try moving it up here because we actually don't call it until the very end of the script. We can see if moving it around causes anything different for us. See if AMSI trigger gives us a smaller chunk of code. Oh, it actually says that that's okay. So let's see if that runs. Oh, and that did work. So now we would now we would go ahead and start trying to modify these so they don't get flagged. What's interesting is if we add in, I'm going to wager that if we do this, just add in this if statement without any of our bypasses in there, that we might get flagged again. We might be flirting like right on the edge of not being detected. Oh, interesting. They must have updated their signatures. This is much easier than it usually is. So that's kind of how the process goes. Do you guys want me to finish this, or are you guys okay with moving on?
There was one question about that process, Jake. John was asking, can I just remove one line, or I think remove line by line to see which line is causing the trigger?
So you can to narrow down some of the bigger detections, like this AMSI and it failed, like type of thing. But unfortunately, you'll get to a point where it's no longer any individual line of code that is causing it to be flagged. It's the combination of lines, at which point it becomes a little harder. That's actually what AMSI trigger is doing. Is it's chunking your code like, well, I think AMSI trigger does it line by line and not by like number of bytes, but I could be wrong. But it's like going line by line, trying to find the smallest piece possible that gives you a detection. That's also what threat check does. Is it chunks your code into like a super small piece, and then when if that doesn't find a detection, it adds a larger chunk and checks it, and then it adds a larger chunk and goes through that process. So AMSI trigger and threat check should theoretically give you the smallest sized piece of detection. They don't always, but theoretically they should be, because that's actually the process they go through. Is they try to start with like one line at a time to find what detects it and then add them together. Then AMSI.fail is kind of a fun one. I actually we were using this the other day for something about 2 weeks ago, and I think that AMSI.fail has some problems in it. I'm having a lot of problem just getting recently just getting like valid executable code out of it. So we can take a few minutes here, have you guys go play with it. I'm just gonna drink some water real quick to give my voice a rest. But it's a pretty cool website. FlangVic built it. You used to be able to hit the API directly, but Cloudflare got mad at him for it. So I think the generated encoded actually works a lot better. Let's see. I think the generate encoded is a lot more successful. Oh, so that one at least looks like it executed. So yeah, so sometimes it's kind of hit or miss on what you're doing. So we'll generate a couple here. We'll try it again. But like I said, I've been having some problems more recently with stuff. But it's a pretty cool tool. Yeah, so if we can get one of these to run real quick. Let's see, let's try this one. Yeah, unfortunately, it's probably finally been long enough that so just like invoke obfuscation, if you use the defaults, yeah, that's what I was gonna say is so like invoke obfuscation is the same. Like if you just use like invoke obfuscation token all, which is like the one that just runs everything automated for you. There's been enough time now that basically like all of the iterations have been flagged, which is a lot. And there's because there's just specific pieces that they can flag inside of it. So it's still possible to use the tools, but yeah, you gotta, like MD said, have to re-obfuscate them because they get flagged now. It's been pretty successful for a very long time, but I think it's just kind of become popular enough and been used enough that all the iterations are kind of flagged now. So now we're going to talk about ETW. So we've mentioned it a few times, like we had that ETW bypass in the payload, and I've talked about how EDRs and stuff can use it. It's actually like an underlying functionality of Windows that was originally built for debugging, but has become this really useful infrastructure for EDRs and defenders to collect data from. It's made up of three primary components: a controller, which builds and configures your tracing sessions, providers, which generates events, and then consumers, which interprets the generated events. So there's like lots and lots of different event providers. It logs like all kinds of things, things from process creation to start and stop, to assembly loading activities, the assembly names, just-in-time compiling events, whether that's your MS build events or like the just-in-time compilers to convert Microsoft intermediary language, which is what all of your .NET programs are compiled into, and just-in-time compiling, using that just-in-time compiler to compile into machine code that gets collected. Event tracing also allows you to configure multiple alert levels, so that you can set up keywords that automatically elevate the alert level, and custom levels that can be set by providers as well. And it actually looks like I accidentally, when I was going through the slides, moved this image down. Sorry for that. Must accidentally hit that. There we go. So it's pretty useful. Custom levels can be set by providers. Like there's actually a, so AMSI doesn't produce logs, like persistent logs by default, but you can actually go start like an AMSI provider and then like collect the logs that AMSI generates itself rather than relying on the alert levels. You still can't get the raw outputs from AMSI, which would be really nice. AMSI has like a numerical evaluation of what a threat level of how suspicious something is, and if it's over that level, then it is suspicious. If it's under that level, it's not. And so like that, it would be super, super useful if we get the raw level, but I've not seen anyone that gets any way to get the raw return, because AMSI seems to round it prior to sending it back. So as we've, as like I was talking about there, ETW can be a very effective way of hunting .NET. And so like when I say very effective, like really, really effective, because in some other seminars we've done and showed, like you can use Silk ETW to collect those events. And like you can go run all of your obfuscation and stuff against like a C# assembly. And there are certain pieces within an assembly file that if you don't go change them, like the assembly name, no matter how obfuscated you get, the assembly name stays the same, stays persistent. There's like GUIDs, or how to pronounce them, that are persistent in the assembly, even if you change the assembly name and things like that, that make it really, really effective to hunt .NET through ETW. ETW also is like the actual underpinning architecture of how all of our log providers in Windows are built. So all the script block logging and all that stuff for PowerShell is also an ETW provider. Everything's ran through ETW. So we can disable the ETW provider for PowerShell, which is this system.management.automation.tracing PowerShell ETW log provider. And if you disable that, we like break a lot of the logs and those kinds of things. It's pretty useful. But it does not bypass like AMSI because they're different providers. So, and then the kind of final exercise we had to do is to disable AMSI and then run invoke mimikatz to kind of show that I believe that it's using the ETW providers looking for this kind of stuff, as well as like doing in-memory string scanning. So we will go do that exercise real quick.
There's about 10 minutes left to class, Jake, just a heads up.
Cool. Oh, I forgot my computer was on Central Time, so I was thinking it was like we had another hour.
I'm sure people would stay around and listen. So, except for Paul. Paul said it's midnight there. So, but Dan said he would. James asked a question while you're getting that stuff pulled up. Do EDRs using ETW typically act as providers for consumers?
They're typically consumers. I'm sure they probably set up providers to send, like if they have like remote stuff to send data. They may also set up their own providers, but they're primarily consumers. Unfortunately, I have a family dinner that I have to go to, so I can't stay around for another hour. But we'll do this last exercise.
If you at Jake on the Discord server, I'll drop the link again. Either me or him will respond. If you add him, he'll talk obfuscation with you all the time. If you add me, I'll talk about whatever, because that's what I do.
Yeah, we're pretty accessible on there. So as we go through this last exercise, if anyone has any final questions, please feel free to ask them now. And feel free to send us emails or reach out to us on Discord or whatever. As Anthony mentioned, I'm a huge obfuscation and evasion nerd, so I'm more than happy to talk this stuff with you guys. So actually, we're gonna go run bypass 2. Okay, so we ran that. So now run invoke mimikatz. This should be unhappy with us. We'll see what happens.
This was pre-obfuscated for you.
Let's see. Oh, that one did work. So let's just try invoke.
As I say, yeah, that looks like it actually is obfuscated.
Oh, I might have accidentally overwrote it last time I topped this. Oh, whoops, I gotta run it again.
I'll answer some questions while you're getting that set up. Lucas asked, when's the next time that we're gonna be teaching the evasion course, and will it be through Eventbrite? If we teach it outside of like a conference, it will be on Eventbrite. At the moment, we're waiting to hear back from a couple conferences to decide what our schedules are gonna look like for 2023. Most likely, we'll probably end up teaching that one at Black Hat again. We are teaching the Red Team course at Black Hat Europe in 2 weeks. That's virtual. The evasion one we did put in for it, I believe, at Black Hat Asia. So we're waiting to hear back if that's going to be virtual or in person, which kind of dictates a lot of our scheduling. since we don't want to offer courses like every other month, try to space them out a little bit more than that.
Yeah.
I mean, I feel like we teach courses every month, but
we're getting close to it.
We are getting close to it.
So we've someone said drop them on Udemy. We've talked about doing it. The problem with doing that is that stuff gets outdated so quickly that like we really don't want to. It's hard to maintain those classes, and we want to make sure everything's super high quality. So we're in discussions about whether or not to do that kind of thing, but we're just a little hesitant because things get stale so fast. Like a lot of the examples and stuff would be irrelevant a month or two after it was published. So like the follow along wouldn't work anymore. I have to, every time we teach this, like I have to go update all the obfuscation and all the scripts and stuff to make sure it works for the students. So it's a little difficult to do that unless we had like an ability to provide like a VM that like we prevented from updating and that kind of stuff. Cool. If there's no other questions, I think we're Anthony and I are going to go ahead and sign off.
Typically takes Zoom about 1 to 2 hours to compile everything, and then once I get that, then I'll email that out to everybody that was on the Eventbrite list. So you guys will get a link for that, and then probably won't get it up onto YouTube for probably like a day or two, just because that takes a little bit more time for them to compile it. Yeah, I figure a lot of people might be sleeping soon. I mean, it's almost 7 for me, so I'd like to go eat dinner. But appreciate it, guys. Thank you for everything. Thanks for showing up. Hit us up on Discord. Everybody get some sleep and go eat dinner. Thanks.